Welcome to Startalk here at BAM. Yes, it is now my incredibly great pleasure to bring on your host, a wonderful man, a hero to science. Ladies and gentlemen, Neil deGrasse Tyson! As promised, there's Neil. I will now bring on our two comedic guests tonight. Ladies and gentlemen, Michael Ian Black.
Hello. Thanks, Eugene.
Hello, Michael. And the always delightful Paul Rudd. Welcome, Paul.
Thank you.
Just to remind you,
So handsome.
to remind you of what Startalk is. It is a
Paul Rudd Fuckfest. Said that wrong.
we like to have fun with science, and we always have comedic co-hosts, and we go live. We have more than one. And now for our science. This is the science side of the house right here.
Sorry.
First, let me introduce. This is her second time as a guest on Startalk Live. She's a professor of cognitive neuroscience at Columbia Presbyterian. Heather Berlin. Come on, Heather. I stumbled, not because I didn't remember her name, but in fact it's Mount Sinai Medical Center, not Columbia. So my apologies there. It's your second time, thank you. This is a neuroscience show, but we have one more guest. And she's, I'm a big fan of hers in many ways. You've seen her on television, you know of her. Please welcome, warm Brooklyn welcome to Mayim Bialik from The Big Bang Theory.
This is a hell of a lineup. I'm just saying what they're thinking.
Yeah. So we're going to talk about the brain. The whole next 90 minutes, 3 segments, we're going to talk about the brain. And you're here because, Mayim, you have a PhD in neuroscience. You don't only portray one who does on TV, you actually have one, right?
Yes, I'm a doctor and I play one on TV.
But you do both. You do both. And so you also have a new book that just came out on being a vegan.
Correct.
Now, okay, we have 12 vegans in the
Hey,
audience.
we're in Brooklyn. There's plenty.
And I try to say, how do I weave veganism into Startalk? And it's
By just discussing it.
so, and I noticed that the United States actually has plans, unfunded though they are, plans to go to Mars by 2030. And if you're on Mars, they're not going to be bringing cows with them.
You just found the perfect way to incorporate it into this evening.
And so, in fact, they're developing vegan recipes to go to Mars because the first colonists there, they want to be able to eat sort of efficiently, as it were.
And not damage the environment of Mars.
But don't we need to damage the environment of Mars to make Mars habitable? Isn't that the entire point?
Mars is just one cow away from being a place people could live.
Well, right, so it's an interesting, what does damage mean? If you change what it is, that's damaging it, technically. If you turn Mars into Earth, you totally messed with it, right? So I don't know if that's a good thing or a bad thing.
Well, was Mars actually like Earth at one point?
We don't know, but we have evidence that it had running water,
Right.
So something bad happened on Mars long ago. And so
George Bush. Just a theory.
So, are you a candidate for NASA to retain as an advisor in this capacity?
No.
Why? You
That's
just wrote a
big
book
no.
on veganism.
No, I wrote a book on the vegan things that I feed non-vegans that they enjoy. It has nothing to do with Mars, space, and I should be on that side of the room to talk about it, not this side.
Okay, so it's tasty vegan food for the skeptic, I guess.
Sure. I mean, I write for a website called Kveller, and I would often write about recipes that I had made vegan, just kind of in passing, and people wanted me to publish them. I'm not like a fancy celebrity chef. Like, I never look like this. I usually am in sweats and an apron in my kitchen. So I wasn't looking to be a celebrity chef and say, like, this is how you should eat. It will make your family perfect. But what I know is what I've sort of cooked my whole life and things that I've made vegan that taste good. This still has nothing to do with science, but I'll be done talking soon.
Well, it does have to do with because being a vegan means you're eating efficiently given the ecosystem. That matters.
Right. So one of the reasons that some people do choose to eat vegan is out of sort of deference to the planet and environmental concerns. It shouldn't cost more to store food than it does to actually give it to people, and sometimes that happens.
Yeah, and so I'm just saying, if you make food that non-vegan people are happy with, that makes you a really valuable person.
Why, thank you.
Just,
Am I the most valuable person?
I don't know. I just wanted to call that to your attention because NASA has an advanced food technology
Should
project.
I be holding this like you are?
No, you don't have to. That's
Now,
fine.
I have a
Everyone's
question.
holding one, but
Maya-
me. Okay, I'll hold it.
Speaking as someone with a perfect family, I have a question about veganism. Is applewood bacon, is that vegan?
It's got the word apple in it. It must be healthy.
Okay, good.
I was just thinking of your book, Pesto Pasta for Martians.
Yes.
That was what you were working on, right? I really think that you should jump in on this conversation.
So if you go to Mars, it takes 6 to 9 months to get there, and then you have to wait for the planets to realign.
By then you can digest the meat you ate last week. What? Sorry. Sorry.
I just want to point out that most people are more omnivores and don't just nobody just anyway. You go on.
So no, you're there. It takes that long to get there, and then you're there for the planets to align again. It's another 1.5 to 2 years or so. So it's a 3-4 year round trip to do this. So I mean, people are thinking serious and hard about this. And until Mars becomes terraformed, you're going to have to sort of make do with plants and what, Paul?
I read this article in.
Nothing good ever begins that way.
Swear to God, and
Except I read this
it's a very
article on the
sketchy
internet.
magazine.
Yeah.
I'll throw it out there.
Which magazine?
We.
Life.
Oh.
Oh, we. We.
Okay.
We, which is French for life. And it was all about, and this was, I want to say it was about 20 years ago, about the terraformation of Mars. And they talked about churning oxygen out of the rocks, creating some kind of atmosphere. Like we contain an atmosphere.
Let's call it an air shield.
An air shield. That's what I'm thinking.
Okay.
It's like an ozone.
Yeah.
That they would descend above the planet, would trap in the air, and we would have these kind of habitrails, greenhouse, where we would grow food. They would populate Mars with about 50 or so people, and over time, it would turn into like Judgment City, where it's 73 degrees and sunny all the time.
And then you could have your cows that you were missing from
Yes,
before.
so you would have cows.
Because a cow is a machine to
You have
convert.
to have like 10 for every person, though, because that makes sense.
No, a cow is a machine to turn leaves into steak, right?
In theory, maybe.
Isn't that's what that is? What else is a cow?
What it was made for,
Yeah.
apparently.
I guess really the only point I just wanted everyone to know that I read Life magazine.
Because you certainly didn't have a question at the end of that.
There was no. In fact, I was kind of I was talking about it, not really knowing where I was going to go.
You used a
with
lot
it.
of big words, though.
Terraformation, guys.
And
Just check it out
atmosphere.
when you get a chance.
Yeah.
Google it.
Descend.
So good luck with the book. And you're
Thank
on a
you.
book tour now. And
Thank you, yes.
We're grateful to the book tour that you were even available to us here in New
No,
York.
it's true. I'm going on Howard Stern tomorrow, but I did the Today Show and Rachel Ray and all sorts of places that people talk about cooking and.
Excellent.
Yep.
So good.
Yep, thank you.
So now another thing we may know you for is as Amy Farrah Fowler on The Big Bang Theory. Now, I actually had a cameo on Big Bang Theory, but I think it was before you, maybe
Yes.
before you became a regular character.
Yeah, I was brought on the season finale of season 3, and then I was made a regular along with Melissa Rauch, who plays Bernadette, about midway through season 4.
Okay, great to have you as a regular there.
Thank you. Thank you.
I'm a fan of the show, and it's a show, if you're not familiar with The Big Bang Theory, it's the #1 sitcom on television, but otherwise, if you're not a TV watching community, it's a caricature of sort of geeks in their lives, and they're professors at, I guess that's Caltech.
It's a group of physicists and one engineer with only a master's, which he's always teased about, yes.
Yeah, and so it's a lot of caricature going on there, and it's been criticized for its stereotypes, and I'm thinking it's a TV show, you know? I mean, just let it do what it has to do. You play a sexually frustrated,
Like every woman in science.
Not every woman.
You preach, sister.
Clarify.
Touche.
you talk, girl. No.
Touche.
So it's just, what's interesting to me is they each have some kind of psychological issues. I think your love interest, who is Sheldon, I think he comes closest to what anyone might describe as having Asperger's or some other kind of non-social behavior.
Right, so so all of our characters are, in theory, on the neuropsychiatric spectrum, I would say. Sheldon often gets talked about in terms of Asperger's or OCD. He has a thing with germs. He has a thing with numbers. He's got a lot of sort of that precision that we see in OCD. And there's a lot of interesting features to all of our characters that make them technically unconventional socially. And I think what's interesting and kind of sweet, and I think should not be lost on people, is that we don't pathologize our characters. We don't talk about medicating them or even really changing them. And I think that's what's interesting for those of us who are unconventional people or who know and love people who are on any sort of spectrum. We often find ways to work around that. It doesn't always need to be solved and medicated and labeled. And what we're trying to show with our show is that this is a group of people who likely were teased, mocked, told that they will never be appreciated or loved. And we have a group of people who have careers, successful careers, active social lives that involve things like Dungeons and Dragons and video games, but they also have relationships, and that's a fulfilling and satisfying life, and I think that's what we really try and show on our show.
I never thought that that's... Heather, there does seem to be this trend in society that if someone finds themselves on some extreme of some behavior spectrum, that you have to put them back in the middle like everybody else. And is that a good? That can't be a good thing, right?
Can I tell you what we in the Church of Scientology believe?
Well, I think there's a movement in psychiatry now. So while I think labeling is important in certain respects because it can help clinicians talk about people in a certain way, it can help with treatment, but there are other negative aspects to it. People can get labeled with something that sticks with them for life, and the
Like
whole
psychopath?
Yes.
Not easy to get around.
It's hard to shake that label. Yeah.
You
actually
try
really
and you try.
It's difficult to treat psychopaths because they don't present. I mean, the whole.
Yeah, because they don't go like psychopath.
Like, I'm a psychopath. No, so people normally come for treatment when they're feeling distressed. And there are a lot of people who are labeled with a disorder who can get on perfectly fine, who don't necessarily need treatment. And even
Then
now—
it's not a disorder, it's just an order.
Yeah, it just has to do with the amount of distress it's causing to the person. And now I think, like the new DSM, which is the Diagnostic Statistical Manual that we use to diagnose different psychiatric disorders, has now actually taken away the label of Asperger's. And now things like autism or pervasive developmental disorder or Asperger's are all put under this name of autism spectrum disorders.
Well, and also Thomas Insel is trying to sort of do away with the structure of the DSM-4 or 5 as we know it, to say more that we are all along the lines of many spectrums, right?
So yeah, so the way so Tom Insel is the head of the NIH, the National Institute of Health, and the way psychiatric diagnosis is going and the way that I apply for grants, let's say, to do research, is that instead of saying I want to study a disorder, because a lot of people with different psychiatric problems can be labeled as one disorder. We're now going to look at these different dimensions and say, okay, is this person having problems like emotional instability or impulsivity, and try to find the neural basis of those particular traits and treat that rather than the disorder.
And never think of it as a disorder. This is good. So the Big Bang Theory is leading the way in this.
We are at the forefront.
It's an interesting discussion. I know, like, I sometimes suffer from depression, and when I get stressed out, I just burn down a building now instead of taking my pills. That works great for me.
Did you learn that from the Big Bang Theory?
No. I learned it from burning down buildings.
Wait. So, Mayim, do they have neuroscience advisors on the show? I met the physics advisor there.
Dr. Salzberg, yeah, David Salzberg from UCLA, a very fine university.
Right. Where you got your PhD.
And my undergrad degree as well.
Okay.
Yeah, we have a physics consultant who, he also has, a vast knowledge of general science, as those of us who are trained in science tend to. We have, a smattering of this and that.
So use him for even the neuro stuff. Then.
Sometimes I am used.
Oh, yeah.
I mean, we have a really exceptionally intelligent, interesting group of writers, many of whom have science backgrounds. But yes, sometimes I get strange emails like, what part of the brain needs to be not working for us to have this happen? Or, what should Amy be doing in her lab? Or we had a couple scenes in the episode we just filmed where I needed to have 3 different activities that I'm doing in my lab. And, Amy's lab is not a perfect neuroscience lab or neurobiology lab. So I tried to at least make things look, authentic for what we're doing. It's not always perfect. Get a lot of interesting comments like, why would she be doing research in social affect in capuchins if she's also counting spores?
I had that question.
Yeah, I gotta say, though, that is a pretty
I watched that episode and I was like, that's bullshit.
Yeah, that's no way.
Anyway.
Social affect and capuchin monkeys. Give me a break.
No, I you don't need me to confer on this, but the whiteboards that had equations on the episode that I appeared,
Racist.
They had. They used to be blackboards. What happened? So it had equations drawn from my research.
Right.
And then the guy asked me, he said, did you recognize something on the set?
It's a nerd fest over there. It's a nerd fest.
And it turns out he got equations from another Tyson doing research in astrophysics, not from me. So, but
Was it
that's
the
okay.
male model Tyson Gay? Because he's wonderful. In the reference nobody got.
So is there in your own life experience or in the show, tell me about women in science. How's that treated and thought about? And
Gosh, I mean, lots of different ways in my personal brain, but in terms of sort of, presenting or representing a female scientist, there were no other neuroscientists at my audition, when I auditioned to play Amy Farrah Fowler. It was a group of very talented actresses, but, as actors, we are paid to play whatever's on the page. We don't have to really be that in real life. So that was really just sort of an accident. I feel very lucky that I had
I was so
that.
disappointed when I learned Raj was not an actual astrophysicist.
Yeah,
He was an actor.
No, we're all actors. But I think when people especially criticize or say it's such a stereotype, I know people like all those characters. I promise. I hang out with them sometimes. I know women like Amy Farrah Fowler. I was asked to do a female Jim Parsons impression. Was literally the audition. I had never seen Big Bang Theory. And I was told they were looking for a female Jim Parsons. I said, that's great, who's Jim Parsons? And I Googled Jim the night before, and I saw about 10 seconds of him doing his Sheldon bit, and I thought, like, I can do that. You know, I know tons of people like that. So I didn't have to present as a scientist per se that way, but Amy is based on a few female professors in particular, and a few male professors as well.
Out of your own life that you've assembled.
I mean, I spent 12 years in academia. I've met a lot of interesting people in neuroscience. So yeah, she's based on a lot of real qualities and real things that exist. And there's all sorts of men and women in science. And you know, there were professors in my department who looked like models, both male and female, and there were those that looked like the characters on Big Bang. And you know, the fact that we present Amy as sort of a, you know, frumpy, like they dress me a couple sizes too big and very kind of low on the aesthetic level, that's not a statement that women scientists can't be attractive. That's a very specific thing that our writers wanted to craft for this Sheldon-Amy relationship. But the Bernadette character is a microbiologist, and she gets to wear false lashes, and she wears, you know, fancier clothes than I do. But I love that I get to, you know, go to work and put on slouchy clothes. I don't have to wear Spanx. I don't have to spend long hair and makeup. Like, it's very comfortable to be that kind of person and scientist.
I wonder, is there any correlation between extreme science talent and absence of social graces? Heather, is there any research? The reason why I ask it, because that's the stereotype. It's been with us forever, and it's exploited on the Big Bang Theory.
Name one stereotype that's not true. Fine, name two.
Well, I mean, so people in academia, there is a stereotype, and the reason for that stereotype is there are a lot of people in, particularly the sciences and engineering, that think very, you know, you have to think very methodically, and the types of personalities, the types of dedication it takes to be an academic is in a sense, you have to be a bit asocial. So I think it attracts people who tend to be a bit asocial, who think very rigidly. You need to be a bit obsessive, compulsive about whatever it is that you're studying.
But is it that it attracts asocial people, or that the field does not reject asocial people the way so many other fields would?
Well, it could be a little...
Yes, Neil, that's what it is.
Well, there's one false correlation. One thing that people think is that it necessitates that high intelligence necessitates these personality characteristics, and that's not particularly true. There's not a high correlation between high intelligence and, say, Asperger's. So I think it's more that it attracts people to that field rather than it's correlated per se with high intelligence.
So, okay, so, and of course, in the Big Bang Theory, everyone there is like wicked smart, right? That's everybody.
Well, it's a bunch of professors at Caltech. I don't know.
There you go.
They're smart people.
You've got, I skipped over a note here. I want to go back to it. After you got your PhD, you were a school teacher.
I taught, I designed a curriculum for neuroscience. I taught in the homeschool community in Los Angeles for junior high and high school. I did basic neuroscience. I designed a course on technological advances in neuroscience. I also taught high school biology in the homeschool community. And
it's
a
so
little bit of
crazy to me because
chemistry.
our resumes are almost identical.
Yeah, I had my...
Wait, my question,
Yes.
what does it mean to homeschool as a teacher that isn't, you know what I'm saying?
That you don't live there.
That you-
How do you homeschool?
Is there a, yeah, exactly. Like, is there a community of homeschool people that all meet up to have their own
Yeah.
secret school?
Yes. Well, so often for higher level classes like junior high and high school science, a tutor or a teacher is hired, and you meet usually in a home. Sometimes people meet in parks or community
There's
centers.
a pack of kids there who are all
Yeah, I mean, I
homeschooled.
taught 10, high school students who were getting ready to start taking community college, and yeah, I was the person on the Big Bang Theory was their biology teacher. It was kind of freaky for them.
Okay, and you've also involved in a STEM initiative, I've been reading.
Yeah, I'm the spokesperson for
Science, technology, engineering, and math.
Magic.
I'm the spokesperson for Texas Instruments, which is the...
Really?
Yeah, I've been their spokesperson. This is my 3rd year, so I had a TI-81. Depends on how old you are, what TI version you had. Yay, there's people my age.
I,
That's
That's the
Calculator.
Terminator that comes back to kill Arnold Schwarzenegger, right? He's the scariest one of all.
That's TI-82. Yeah, that's right.
and Mel, what is a TI-81? Say we're
So
not
it's
whatever
a
the age
handheld
they
graphing
are.
calculator. So I got mine, I think, when I was 14, and that same graphing calculator took me all the way through junior high, high school, into college and grad school. But there's a new one called the TI Inspire that now is in color, and you can download images, and you can create parabolas from basketballs being, images of basketballs being shot. It's exciting. And so there's also a bunch of physics. There's a bunch of physics and chemistry stuff.
I had no parabola machine.
Okay, well.
But I had a notebook that was great, covered in bands I liked.
Can you type in those letters and then
Yes.
when you hold it upside down, it says hello?
Yes. You can still do
You know
that.
it's good then. You know it's a good one.
Yes.
In my day, there was the TI people and then the HP people who had reverse Polish notation, and those were the cool kids.
There's still that debate going on when
I'm
I go
just
to
saying.
conferences. Yes.
I'm just saying.
In my community, it's between Twizzlers and Red Vines.
You can spell boob in both.
So this is what they do with the calculators we got.
I know.
So Mayim, there's also everyone has odd relationships with their parents. Yet you're in the show, in the Big Bang Theory. Yeah.
Go on, Neil.
Wow.
Yeah. But your character, we don't know your.
So there was.
Will your family come into a future
There was
episode?
one episode with, I'm laughing, it'll be funny in a second. There was an episode where Amy wants to convince her mother that she's dating someone. This is before she and Sheldon were dating. So she asks him to pretend like he's her boyfriend, and they Skype with her mom. So there was a mom scene. And he says to her, because he's trying to convince Amy's mom that they're dating, "I just made love to your daughter's vagina." And that was the end of the Skype call. Sorry. Is that okay to say?
That's okay to say.
I didn't write it.
I don't get it.
I'll tell you later.
If you can say it on
Science
CBS.
Well, on the subject of sex, in the Big Bang Theory, there's a lot of sexual tension everywhere. You have some
In restaurants, in butts.
No, you have some. So Mayim,
Yes, I'm listening.
you have this sort of dual attraction to Sheldon and to Penny.
Amy is bi-curious.
Bi-curious, there's a word for that, okay?
We're in Brooklyn, of course there is.
It's bi-curious, and it's charming to watch that. as
Yeah,
it
there was
unfolds.
a lot in season 4. There was a lot of the understanding that for some people, and Amy was one of them, who arrive late to kind of social interactions like that, and especially sort of sexual feelings and feelings of intimacy, there's an appreciation of all kinds of beauty, and obviously Sheldon is very attractive to Amy for a lot of reasons, but Penny is as well.
And there's also Raj. I think he's bi interest. What's the word?
Bi-curious.
Bi-curious, yeah.
He and
Are
Howard,
you learning about bi-curious right now?
Yeah, just the word.
That makes me very happy.
Yes, Raj and Howard have a very special relationship. Terrible.
Somebody doesn't go on Craigslist.
Yes.
Well, to take us out of this first segment, there's an episode, the Gothowitz deviation, I think it was called, where there's a discussion about modifying people's behavior. And Sheldon modifies Penny's behavior by offering her chocolate. And she changes her behavior like instantly, essentially, for this. And that brings up the question, do you modify behavior by training people to learn how to behave? Or do you just reward good behavior and punish bad behavior?
Depends the behavior. I'll let
Yeah,
you
yeah.
take it.
Where are we on that? And like B.F. Skinner was famous for
Well, B.F. Skinner's idea was, he took it to a very far extreme. Behaviorists, they all thought that we're
and he did this with his kids.
He might have, yeah.
And you have a newborn, I
I
understand.
do. She's 3 months old, and
3
I'm
months old,
experimenting with
3
her
months
as we
old.
Isn't it
speak.
fun
Yeah.
to be a scientist with kids?
Yeah, it's amazing.
I know.
I like put her in front of the mirror. Do you recognize yourself yet?
So these
It too.
She's gonna be messed up.
yeah. Are these the children who write books about their parents when they get
Exactly.
older?
My mom was the neuroscientist. She messed me up.
Yeah.
But no, so his idea was that we're born sort of tabula rasa, blank slate, and you can make anybody into anything just by training, by giving them rewards and punishers and modifying their behavior accordingly. What we know now is that we're born with certain genetic predispositions to behave in certain ways, and then within that sort of within that range of you can modify behavior within a range that you're given biologically. So for even something like intelligence, for example, you can be born with a genetic predisposition to be within a certain, let's say, IQ range. Then your environment can push you sort of towards the top end of that range, or maybe towards the low end of that range. But you'll never exceed. So it's almost it's as everyone says, it's a combination of both. But there's definitely a lot of learning that occurs, and we're knowing now from mapping out the brain and looking at the genome that what seems to be most affected by the environment is the way the brain gets wired. So you're born with certain genetic predisposition in terms of the structures of the brain.
We've got that in another segment, but let me just ask
yeah.
you, can you teach someone math faster by giving them candy than just by teaching them? I mean, I'm just wondering.
Yeah, well,
Or
actually,
holding them underwater and being like, learn it, and then raise it. Waterboarding. I guess I'm describing waterboarding. A towel on the face, a little bottle of water, and some math.
Well, we know that people sort of discount delays with rewards. So if you give someone like a reward right away, they'll put more emphasis. They'll want that rather than waiting for a reward
Well, I think
later.
the issue there is motivation, and not necessarily sort of a skill set and a cognitive ability or a technical ability. So
Right.
the fact is, yes, candy makes everything better, no matter what you're trying to learn, because it's a very strong motivator and it's a potent motivator.
It might not make you better at math, but it might make you study for longer, for example.
Well, and also
What
it's a
will
great
cocaine do for my math skills?
Yeah, a kid can learn French in a week on heroin. Now that's a reward.
So a little of both might help, I guess.
Yeah.
I mean, this is the gold star that children get in elementary school, right? That's the.
I mean, it does work to a certain extent. As I said, it'll help motivate behavior, but it won't sort of give you a skill set that you don't sort of have.
Well, and I think also as parents, it's one of the early things we learn when we're talking about how we discipline children. And waterboarding, joking aside, threats and fear and punishment and pain are very, very strong motivators to change behavior. The do you want to condition a child with fear is a much larger question, which is probably not funny at all, and I won't go into it.
Yeah, but there's positive reinforcement and negative reinforcement. There's also taking away of a positive, which can be another way to help somebody learn. So there's a whole variety of ways you can model behavior.
I thought about taking away. So someone lives with a positive, you threaten to take that away.
Like
Right.
a finger. Don't tell me it's not a positive. I don't have a child, so it's fine that I'm saying all this.
I have 2 children, and it's fine that you're saying this.
One last question before we take our. By the way, our breaks are short. Just to regroup here. So on several
It's going
episodes.
to get crazy in about 30 seconds.
Yeah.
On the shows, you have like live rhesus monkeys or something. Are they projected in, or are they really on the set? I'm just
They're
curious.
fantasy monkeys that you have to imagine and it appears on every screen. Yeah, we have real capuchin monkeys.
Wow. Because
Yeah. I'm a vegan. You shouldn't ask me too much about that. Acting monkeys.
Yeah, no,
That's
you-
what I am. I'm just an acting monkey.
On Ed, you had real Reese's Pieces, right? On the craft service table?
Yeah.
I remember you talking about that, yeah.
Did they ever try to grab you?
when we come back on Startalk Radio, more from the Brooklyn Academy of Music, Startalk Radio. Give it up for our panel.
Thank you. Yeah, I'm gonna go. No?
I want to thank you all for coming. We've got 2 more segments. Each is about a half hour, and then we're going to open the floor to questions. We'll have a microphone in the aisle, because that's how we roll. Can I get the house lights up just briefly? There's someone in the audience I just want to introduce to you all. There's a... Bill Nye!
He follows me everywhere.
Science rules. In inertia is a property of matter.
Can we have a seat here? I'm gonna put Bill on the panel. Why not?
He should probably, yeah.
That's okay.
He should go between science and comedy.
Right here. There you go. How you doing, Bill?
Fabulously.
You happen to be in town. Thanks for showing
Oh,
us.
sorry. Let me
He's following
me
me.
get the
We just
dummy
did
mic.
Bill Maher together.
I'm great, Neil. Thanks.
Yeah, there you go. Bill Nye, the science guy.
I think
Thank you.
Now, Bill, you're not actually the person who I was first going to introduce. Can we bring the lights back up again, please? The house lights. So we have in the audience.
President Barack Obama.
No, he doesn't know he's being introduced. He didn't know this, but Phil Larson, please stand up. Where are you?
Phil.
Where are you? No, there he goes. Phil Larson, everyone, is... Okay, you don't know who he is yet. Hold your applause until you find out who he is. He's...
The first person to ever eat a baby.
Office of Science and Technology Policy.
Phil Larson comes to us from the President's Office of Science and Technology Policy. So he's representing the White House here at this Startalk. Thank you. Thanks, Phil, for coming. All right. Okay, the lights can come down, and we will begin the second segment. Are you ready? Okay, okay. We're back. Startalk Radio live at BAM! And Bill, thanks for joining us.
Oh, no, it is I who must thank you. No.
So, we want to take this deeper into the brain. We are all neuroscience today. Heather, what is consciousness?
we're gonna start easy and then build it up.
Yeah. What is consciousness?
I mean, that's a great question.
And self-awareness?
Don't pull any punches. Just let us have it.
And you know what my biggest question is?
Yeah.
How come identical twins don't think they are each other?
That's your biggest question.
Yeah.
I mean, why am I me and not you? Well, you can say because we're different people. But if you have an identical twin, you're the same person, but you're not.
Oh, just by that much. Dr.
So
Boyd.
what's up with that?
Well, first of all, what is consciousness? We can define consciousness very simply as first-person subjective experience. So you only are aware that you have it. I don't know what your consciousness is like. I only know what it is from internally. So what is consciousness? First-person subjective experience. How is it tied to the brain? We're still trying to figure that out. Now, that's different than self-awareness. So you can be conscious without being self-aware.
Like in a coma or asleep.
Yeah,
No?
there's
Like my old boss.
there is.
Pretty good.
Bill, I don't think you ever had a boss.
Oh, no, I used to have a job, Neil.
Yeah, you did? Okay.
Yeah.
Well, so for example, babies, they can be conscious, meaning you can have raw sensations like seeing the color red or feeling something soft or smelling a rose without being aware of oneself or having sort of metacognition, like thoughts about other thoughts, or I'm the one having these thoughts.
So if we're going to say another animal is not conscious but is not self-aware but has consciousness,
Exactly.
The bee finds the flower and nature goes on.
There are syndromes also where we see that people have an experience of being conscious, of experiencing things in the environment, correct? Without a notion of concrete self-awareness?
Yeah, there are certain dissociative disorders where people lose their sense of self, but they're still conscious. So consciousness is very unique. You don't need to have necessarily memory for it. You don't need to have self-awareness. You don't even need language.
Alec Baldwin, in his New Yorker essay, seems to be displaying this. Is that right?
It's an article you read.
Yes.
Yeah.
I read articles.
Just check out this one in Life magazine I read about 20 years ago of the terraformation of Mars. I'll tell you about it later. This was great.
So you're saying a baby could hear Bruce Springsteen but like not know why it's having so much fun?
What about like lucid dreaming?
Ooh, yeah.
I mean, is that?
Yeah, so I mean, it's just another form.
There we go. No, you fill in the blank.
It's another form of awareness. Your brain is in a different state. It's conscious, but it's just in a different state of awareness.
What is lucid dreaming as opposed to dreaming, and you think
So
a lot about it?
lucid dreaming is sort of when some people are able to be in a dream and know that they're themselves dreaming,
yeah.
and they can sort of control their dream.
Can I say, been there, done that?
Oh yeah. Was it good?
Well, it's pretty good for me. For me, it was
awesome.
smoking.
Well, wait, so a lucid dream is a dream that you're self-aware you're in?
Yeah.
I have these all the time where I often, well, I mean, I speak other languages. I speak Spanish and I speak Hebrew, and I will often have a dream where I'm
Enough,
trying to.
We get it.
The PhD wasn't enough, apparently.
Anyway, sometimes I will be trying to consciously figure out how to communicate something in my non-native tongue. I know that I'm having a dream where I'm trying to communicate, and I'm literally computing what to say and how to say it and in which tense. But I'm very aware that this is going on.
Yeah, so normally in a dream state, the part of the brain called the prefrontal cortex is sort of down-regulated. It's sort of decreased in activation, so that you're normally not so aware of what's going on, and these subcortical sort of processes are allowed to sort of come through without being
The
monitored.
subcortical process.
Subcortical processes that are
Processes.
the limbic system, the emotional part, the
amygdala?
the amygdala is
Yeah,
part
yeah.
of that.
This is the reptile brain.
The reptile brain, yes.
The reptile brain.
is
The
Once
things
again-
I don't admit I know.
And normally, and so it's very active in a dream state, this reptile brain, this limbic emotional brain, and the prefrontal cortex isn't
I
really...
have erectile brain.
Yeah.
I'm familiar with that. Is that what you said?
But in lucid dreams,
Reptile brain. Yeah.
One thing leads to another.
in lucid dreaming, you can be in a state where you can actually engage the prefrontal cortex a bit more and have some self-awareness infuse this dream state.
So do we
if you're-
see that on an MRI while somebody's asleep? Are we able to do that? Or can
Yeah.
you light it up while someone's unconscious?
So there are a lot of studies, sleep studies, which usually don't use MRI because you have to put them in a
Jump,
sort of
jump,
scanner.
jump,
Yeah, it's a very
jump.
loud, and they can't sleep.
Exactly.
Exactly. It makes a lot of noise. So there are EEG studies which look at different sleep states and dreams. Yeah.
And so with this, so you tell me, asleep you are conscious, in a coma are you conscious?
So that's a really interesting question. So there's new studies now that are showing there's certain people who are in a coma. You can actually put them in a scanner, the one that makes all the loud noise, the fMRI, and you can say to them, okay, we want you to imagine either, say, walking through your house or imagine playing a game of tennis. Now, they can't respond at all. And we know what a healthy person's brain would look like if they're imagining walking through the house or imagining playing tennis. And there's been some cases of people who we think they're in a coma and nothing's getting through, but if you just simply tell them, imagine this, their brain lights up in the right corresponding way.
So hence this story, I thought maybe it was just fiction, where you can read books to a person in a coma, and they might still be...
Yeah, and it's not every person in a coma. So I think they did this with a whole group of people.
If you
and
want to
there was-
hedge your bets, read the book.
Yeah.
Read the book.
Yeah, just in case. But it was maybe like 1 out of 50. They found this person really was having awareness.
Okay.
Do those people, are those people more likely to emerge from the coma?
Yeah, so exactly. So they now have something called the PCI, which I think is called the Perturbation Complexity Index. But basically...
Yeah, that's it.
Yeah, that's it. What they did was so what you do is you actually sort of zap a part of the cortex with a magnet, called transcranial, TMS, transcranial magnetic stimulation, exactly. And then you look at if there's a cacophony of activation in response to that, almost like if you hit a bell and you hear it ring and it's really loud. You know that there's a lot of connectivity, and those people are more likely to come out of the coma than if you just give them the TMS and the activation only happens locally.
And do those people ever have memories of their time in the coma?
That varies. Some people.
And also, this is a very small N we're dealing with.
Yes,
Like, to run the stats on this kind of thing of, you'd have to take so many people who would qualify for this kind of coma study. It's a very small N. I wouldn't be, sort of making any...
Oh, no,
grand-
obviously,
Not
I think,
you, but
yeah.
other
Stop
people.
bickering.
That's...
It's a small N. That's what you said, a
I
small
see it
N.
as small N.
Let's
Yes.
let the
Small
record
number.
show, Mime said small n, meaning small sample size.
It's an
Thank
integer.
you.
Not a very, it's not going to be a fraction. It's not going to be a rational. It's going to be an integer.
Right.
Well, let me get back to that.
That's what, and it's a tradition of mathematics.
Yeah.
We are geeking out.
So in terms of the brain, we tend to think, well, there was the tabula rasa, is it, you draw it up, and then is it ossified by adulthood? But there were all these ideas, hypotheses running around. NASA did a study on neuroplasticity, your brain in space. Okay, told you I'd bring it back to space. All right. So they were checking, in space, you are in 0G, and so in 0G, we have interpretive dance for 0G. Bill, that did not happen in the movie Gravity. People's hair did not stand up on
Dude,
end.
I'm so down.
Yeah.
This is a radio show. So I
Yes.
took the hair and pushed it up straight as though they could have done with a little hairspray in
the movie Gravity. Yeah, they didn't do it. Didn't do that.
I mean, FCOL.
So
For
your
crying
sense
out
of
loud.
balance, which requires knowledge, your body's awareness of gravity, a gravity vector, other things, your vision, your sense of day and night, because in space, if you're orbiting Earth, the sun rises and sets every 45 minutes. So this can totally mess with your rhythms. And they did a study, and they found out that the brain has plasticity to it, where in fact you will completely adapt to those changed conditions. Not only that, the brain builds new brain cells, and in some cases permanently responds to this environment. And so, because of the permanence of some of this plasticity, they were suggesting that you should not bring kids into space because they don't know what a permanent change in a kid would be like as an adult.
What is it like in an adult? What happens in this? With the what
You
is the
go
permanent
crazy.
Yeah. What's the result of this neuroplasticity?
Well, I know people have their eyes change shape, right? Astronauts have had
Like
vision
squares,
problems.
like they become a square?
It's like that thing for making when you have the hard-boiled eggs and you compress them and
Which
the
part of the
refrigerator.
eye? I need you to be more specific.
Yeah.
Like the whole
They're-
eye?
guys who go into space with fighter pilot eyes come back and they don't have very good close-up or distance vision.
Ah, okay.
They
Oh.
need glasses when they get back permanently.
I'd be careful though when you say permanent changes, because if you're talking about neuroplasticity, if it could change one way, it could also change back another way. But I think the reason why not to bring sort of developing brains into space or children is because they're critical periods of development. And if they miss certain kind of stimuli during that critical period, then there could be
Well, and
problems.
you're talking about circadian rhythms, correct?
Among other things, yeah.
Okay, got it.
Yeah.
Got it. So talking about our I don't want to say awareness, I mean it with a lowercase a.
Okay.
Our awareness of day and night. You're saying those things can reset so that you have a normal body period that is shorter than what it is if you are on Earth.
Not quite a 45. Well, it really disrupts your sleep cycling,
Sure.
and you don't get as deep a REM sleep in
Right,
space
so
as
all
you
of
do.
that developmentally would be really, really a bad idea.
But here's what
Not to mention, like, my kids are a pain in the ass on just like an hour-and-a-half flight. Could you imagine sending them to Mars?
I take it you sort of can imagine. So,
I hope it would be like JetBlue, where you at least get some television or something on the back to the seat.
So here's what I wonder, Heather. If there's this neuroplasticity where your body can adapt to stress in the ways that were measured in space, why don't we adapt more on Earth? Why do people stress out and end up in mental hospitals? How much?
Oh, wait, those are two very different questions. Those are two.
I thought he was going to ask about working a night shift. Like, isn't it hard to work a night shift?
Exactly.
No. Why are they two different questions? If your brain can adapt with all this plasticity that the neuroscientists are boasting of, then why do we have people just freaking out here on Earth?
Well, okay, they're two separate things.
Tell me why.
So you can, well, this is one thing. I went around and actually met people who had extraordinary abilities way outside the norm of what we think is possible. Extraordinary memory and, a tolerance to pain, all these things. So
You hosted a TV show on
there
that.
was a Discovery Channel show called Superhuman Showdown, and there were people who we went around the world to find people with these extraordinary abilities. One person could hold his breath underwater for 22 minutes. And amazing. And, I saw it there.
And not be dead. at
And
the
not
end,
be
yeah.
dead. And he could actually...
Okay, just checking. Yeah.
Could he talk to fish even just a little?
But it's amazing how far we can actually push ourselves, our physiology and our brain. So I think a lot of what people stress about is they think they can't adapt, but really we can adapt well beyond what we think we're capable of doing. Why people are in mental institutions is another question. I think there are different, there's a lot of different reasons why people go insane, so to speak. But I don't think it's because of lack of neuroplasticity. Does that make sense?
I support that completely.
Okay, as my fellow.
Not even people who are super, super sad.
Is it because of heavy metal music?
That beat.
As I was saying, you can modify the brain within certain biological constraints. So if you're born with a certain predisposition, or you're just structural differences in the brain, you can only push it so far. But we can definitely go far beyond what we think where we can go.
So do you think, if we see someone else who has ability, and they're human, then can we also try to have that ability?
Again, it's within a certain. So these superhuman people who I met, they all practiced a lot of hours dedicated to it. But they also had certain sort of, like the guy who could hold his breath underwater had a greater lung capacity in general. He started out with that, and then he pushed it further and further. So I think we can all go further within our particular
There is this
range.
book, The Sports Gene, that talks about sort of the exceptional athletic ability that we don't really think about when we see Olympic athletes. They're at a whole different physiological level than we even would think about. We would think, Michael Phelps is a great swimmer. No, like his arms are really, really long. His feet are practically webbed. Like his body is different than ours. He's really different.
No, it is weird when you watch swimmers at that high level. They go about twice as fast as a normal
Their
person
bodies are
swims.
like
It's weird.
you can swim. I could swim all day. I'll never look like that because I was not born with the genetic predisposition to have really long arms and webbed feet.
I think you look great. Doesn't you look great, everybody? That's really what matters. I have a question, but on a sort of more pedestrian level, talking about sports. You see certain populations, like people from the Dominican Republic, which is such a small country, but have a large proportion of people entering the major leagues of baseball. Is it because they have peers?
This is such a dangerous question we know you're about to ask.
Because you're going to change it to synagogue. You're going to go to synagogue.
I was not going into racism, although I will if you want me to. It was about something somebody else asked about sort of observing other people in peer groups ascending to higher levels and therefore seeing firsthand what's possible. Does that make you more susceptible to those possibilities?
I think that's, you want it or you want me to take it?
You can go first.
Well,
Take this, ladies.
Well, I think to keep it simple, we're going to just keep it simple and say that's a huge sociological, environmental, behavioral sort of influence, but I don't know.
I know, I'm writing my dissertation on it.
Sorry. Okay, now it's your turn.
Well, I think.
But have they found a gene for baseball? That's really what he's asking, right?
You're born with certain genetic predispositions towards, maybe better athletic prowess, but it gets dangerous.
Different distribution of muscle fibers, for example, in runners.
I think the reason people are getting sort of, the thing we're dancing around is it can be very controversial. There was a book written called The Bell Curve, for example, about intelligence, and it said, okay, we did this whole study and looked at populations, and X number of people from a certain type of background have the highest IQ and others don't, and it really can lead to...
Ashkenazi Jews.
It happened to be Ashkenazi Jews, but it was...
Who have the highest IQ?
Yeah.
Yeah!
Wait, me too.
That's right.
So, let the record show, Dr. T. I did what I could.
That's 5 sevens.
I did what I could to slip in a joke about synagogues and the Major League Baseball players that they produce.
Is that where you were going with that?
That's where I was going, because another factor as a baseball fan, another very strong motivator in those countries is this: you can play baseball all year. I was just in Minneapolis this morning. It would be very challenging. And that's because the snow is white, the ball's white. It's hard. And then you also have this. You also have this extraordinary motivation of money. You can make it in the big leagues. And have you ever seen that the World Baseball Classic?
Yeah.
Yeah.
It's
So
mostly like Latin America.
Extraordinary players.
Yeah.
Just extraordinary players, but it's one more click to hit it.
I'd like to change the topic.
Yeah, we'll go on.
To ice hockey?
I want to know about sleep.
Let's talk about eugenics
sleep,
for a
sleep.
moment.
Oh, man.
I want to
Why
talk.
is it that people from Boston are just so soft? The face is just such a soft, beautiful face.
Eugene is from Boston. Yeah. So Heather, I want to talk about sleep for a moment.
Yeah.
Why the hell do we have to sleep? So what a waste of time that is, I think, to
Did you
myself.
just say, why the hell do we have to?
Yes!
We could be literally learning karate instead.
No, I'm just saying.
Every time I sleep, I'm like, I should be learning karate.
I'm reading, I'm learning, I'm having fun. I say, damn, I got to go sleep be semi-comatose for the next 8 hours. If an alien came to Earth and you're having a great conversation with them, say, excuse me, I have to lay semi-comatose for the next 8 hours. I'll get back to you. They'll wonder, what's wrong with you?
Maybe they go down 16. You don't know.
No, I know, man, maybe. So
Like a baby.
Well, it's
why
sort
do
of-
we sleep?
The latest sort of theory that we think that most of the neuroscientific evidence is pointing towards is the way of the brain to sort of clean itself out. So during the day, you're taking in all this stimulation, and it's almost impossible for your brain to kind of integrate all of it every day. It would be cluttered. So at night, what happens is there's sort of a pruning. It solidifies the information that it wants to kind of keep and reinforces.
Whether or not it's accurate or correct or anything.
Yeah, it depends.
That's the psychopath.
I just had an example.
There's sort of a pruning that happens, and so without this cleaning out process, they've looked at people when you deprive them of sleep, and it causes all sorts of problems, including it can relate to things like Alzheimer's, because the plaques and tangles that form, actually, that sleep is a kind of a way that helps clear out those plaques and things that could potentially form the proteins.
So you're saying people who don't get as much sleep
No,
as
well,
perhaps...
no.
I'm just asking.
To be clear, she's saying people with Alzheimer's are simply extremely sleepy.
What conclusion are we to draw?
If you're sleepy, you're gonna get Alzheimer's.
That's how science works.
So remember, play baseball.
It's complicated.
All right, so
Well, like for memories, for example, like if you're studying for an exam, actually, you'll do better if you get a good night's sleep. It's not good to just cram the whole night before, because the brain can then solidify the kind of associations that were made and get rid of the nonsense and the noise.
all right, but some people sleep 5 hours, others 9. Should the 5-hour person be sleeping more or the 9-hour person be sleeping less?
That it's hard to say. I don't think there's an exact number on it. I mean, there's a lot of things out there that say you should get X number of hours of sleep, but really everybody's different. Some people just don't need that much sleep.
I don't get a lot of sleep. My feeling is if in general we are productive, functional, getting the things done that we want to get done, there's going to be some variability there for sure.
Okay, so also if you don't get sleep, that's like a form of torture, right? Your brain goes crazy.
What happens is people start to hallucinate. Yeah, they start to sort of because again, the brain isn't able to properly prune out, and all the information can get kind of jumbled, and people.
Also, if you disrupt REM sleep.
Exactly.
But it
REM
is
sleep is where a lot of that happens.
It is an individual thing, because you have people like Edison or Winston Churchill, or these high-functioning people who slept for 4 hours a night or 2 hours a night.
There's actually a large number of people like that. Bill Clinton is another one, Margaret Thatcher. They would only sleep a very few hours, but then they would take these power naps during the day. And there could be something to that. But they all said at least they take those little mini naps, and that maybe the brain can sort of revamp itself
They
during
also
that
have a
time
giant
period.
staff and many assistants.
Are you describing mini naps or hooking up periodically with people throughout the day? Both sound relaxing.
Depends on the people.
So what they found was that the REM sleep was disrupted by astronauts who, in orbit, see sunrise, sunset every 45 minutes. They couldn't get the rhythms going.
Then
They
usually
could
you
just
have
pull
to,
down the shades, couldn't they?
I would have thought. I would have thought.
Those masks that cover your eyes.
I would have thought. You'd think.
Well, it's all coach class. That's the thing.
It doesn't come with a little thing with a
Yeah, they don't give you the little pouch. Yeah, it's not even-
Tell me they flew the space shuttle coach class, and they didn't get the little eye covers.
But studies show that if you deprive people, particularly of REM sleep, that they have to make up for it later on, so that they'll have more hours of REM sleep when you allow them to sleep later.
Okay, so this is a feature of our human species, not a failure of our design.
Yeah, I mean, if there was, if we could design it better without sleep, that'd be great. But so far, it's
But it's all species, right? There's no species that does not need sleep.
I don't know that. I don't know.
I
Sea
don't know.
jellies? Squid?
Algae.
Fish?
There are low metabolic periods, I would say, for all sorts of vertebrates, yes? I mean, at least.
Yeah.
And
There's
no-
always
well-
a rest period. There's a rest period. Even if it's not what we call sleep, there is a rest period.
But from an evolutionary standpoint, one could ask, if it's a big advantage to need less sleep, would these people be more successful, become captains of industry, and get extraordinarily wealthy? And
Well, there
what
must
were
be
you gonna-
something, well, the answer is there must be something advantageous, i.e., incorporating a tremendous amount of input from the day that can then help you make different kinds of decisions, more complicated decisions, correct?
Yeah,
The next day.
Oh, I see. So the digested information has more value to you the day after, as it's for your
If
survival.
that were evolutionarily
Exactly.
advantageous,
Okay,
that's
I
why
got
it
that.
would
That's a
be
good one.
retained. Thank you.
That's good.
But there's
I like
some
that.
animal. I think maybe it's dolphin. There's some animals that sleep with only half their brain and the other half is alert. It's dolphins, where it's part of them is aware for any sort of, let's say, predators coming, and the other
Samurai.
part is sleeping.
The people who sleep
Navy
with their guns
SEALs.
and swords. Yes.
Yeah, samurai bears.
And is it true like lions sleep 20 hours a day, something like that?
Yeah, is that true, Heather?
I don't know everything about
That is true.
everything.
That
You're a
is
cognitive neuroscientist. Do lions sleep 20 hours a day?
They do. They sleep for 20 hours a day. They hunt
Was
for
that
blood.
Time magazine?
No,
You went to the zoo with your kids.
no. I went on safari once, and that's true. And I remember learning that. And by the way, it's
Paul Rudd read it. No, he
the
experienced it.
females do all of the hunting, and then the male lions just go in and then eat first, swat away the kids, and then they go back to sleep.
Yeah. It's just sleep.
Yeah.
Sleep.
So they're called and if there's a bunch of them, they're called a pride. Wow. a pride of lions. Yeah.
A murder of crows.
A boring of panelists.
A smack of sea jellies.
Mime, how much sleep?
That sound is disturbing to any
It's
just
true.
to the nurse.
We can all hear it, so
Okay,
we're all
got
fine.
it. Okay, good.
I believe it is
Show me a
feedback.
test.
It's
A high
feedback.
frequency sound entered our earpieces moments ago. Mime, how much sleep do you get a night?
I'm like a 5 or 6 hour person.
As am I. I'm like 5.5 hours, exactly.
Yeah.
And I'll nap something on the weekend, but during the week,
I
I'm
take
5.5
a
hours.
Saturday, a Shabbat nap for about 20 minutes.
Yeah,
Yeah. I give my kids a cookie and I say I'll be a much better mother if I can sleep for 20 minutes on this couch with earplugs in. I promise.
And how
works.
old are your kids?
5.5 and 8.
Whoa.
Yeah.
Yeah. So presumably when they were much younger, you got no sleep. So
Yeah, I mean, honestly, it's amazing to see what it's like with a newborn. I was a breastfeeding mom, and I was up literally every 2 hours for about 4 or 5 years. Literally every 2 hours.
did you study yourself at that point?
I wrote my thesis while breastfeeding my older one. I literally laying down, nursing, and typing. I was doing data analysis and writing and editing my thesis with my first son. And but it's amazing to sleep again.
And she knows 3 languages.
Totally impressed.
Just get 5.5. How many hours of sleep are you?
Now I have a 3-month-old, so
Yeah, okay, but-
and I'm breastfeeding, so it's
This
like,
is her most restful part of the
This
day.
is I'm sleeping right now, actually.
Half your brain, you're a
My brain
dolphin.
is up, and the other half.
She's a dolphin.
Bill?
I need 7.5.
You're
Furthermore, I claim I'm skilled at the power nap. I put in the hours.
Okay.
I put in the third of an hour on the power nap.
Power nap. Paul?
It really varies. I guess probably about 6 or 7. Although it seems now I am falling asleep for that 20-minute power nap. I don't mean right now as we speak, but at about like kind of 5:30, 6 o'clock at night. Generally, if I'm flipping around and I'm watching Pardon the Interruption, I notice that I fall asleep or show on ESPN.
Yeah?
About 14.
Good.
Around 14, yeah.
Yeah, like 6 to 8.
Yeah, okay. So there are no
Is
nines
that
up
weird?
here.
No.
I always sleep 5.5 hours. I'm normal. 6.4 hours. I'd say 5 to 8 with a lot of afternoon naps after I type out my weird things.
While breastfeeding.
While breastfeeding. cat! Not a human.
A dragon.
I breastfeed a really cute dragon.
Okay, oh, by the way, when all this is over, the bar is open, and there's a special drink that we invented just for this program. It's called the Brain Freeze. So you just go up there, ask for the Brain Freeze. We invented it. The drink did not exist before tonight, and it has sort of the color of your brain, of brain matter, but it's really tasty.
It does sound good.
A great and it's really, really cold.
Kahlua, milk, and nails.
So check it out after the Q&A. So, you ready to go back in?
Sure, let's do this. Let's do this, Neil.
Yeah. We're back. Startalk Live at BAM. We are talking about the science of the brain, and I want to know what the future holds for us. I've got it written here that we have 100,000 miles of nerve fibers in each brain. That's extraordinary. That's a hell of a computer. But it still has issues. Like, no, I mean, seriously, there's brain failure in some people, right? I mean, so what is the hope for really disentangling what all this is and perhaps being able to fix people who have problems? You just go in and snip a connection or nip and tuck. What is the future of this?
Well, I mean, it's a huge problem, actually, to solve, to understand how the brain works. And you're talking about 100 billion neurons with a quadrillion connections, possible connections. So to understand the workings of the human brain is one of the greatest mysteries, and we're all working on that very, very hard. But once we understand how it works, then just like a mechanic has to know how the car works so that when you bring it in, when it's broken, they know how to go about trying to fix it. So knowing the underlying structure is the beginning.
But isn't that reductionist? Not to get all philosophical on you, because in physics, you can describe each molecule of air careening off of another one, but that description doesn't give you the bulk properties of it. You need to sort of step back and say, this air has a temperature. The individual particle doesn't have a temperature. We have macroscopic descriptions of things that enable us to function, because you can't describe every single little thing. Do you think the brain will be intractable in that way?
So there's what you're trying to say is that if we understand everything about the brain, will we understand the mind? Or that's what I think you're saying?
Yeah.
So that would mean that some people think that the mind or consciousness is an emergent property of the brain.
Right.
And
it just happens. Is that what you mean?
Well, it emerges out of the workings of it.
Yeah, if you have enough circuits, you're going to get a mind.
You're going to get this thing called consciousness. They're different. There's something called the easy problem of consciousness, which isn't that easy, but is to say if we can correlate every single thought with the actual workings of neurons in the brain. And let's say we can map all that out and we can do it. We solve the easy problem. But there's still going to be a hard problem of why is it that those neurons firing and those neurochemicals slushing around cause us to have these subjective experiences. And we might not be able to, they call it the explanatory gap. We might not be able to fully explain that. But I think we have to start somewhere, and just understanding the workings of the basic system is a good place to begin.
Can I ask a really maybe dumb question, maybe not? Do we know that consciousness exists in the brain?
I would venture to say yes.
Well, let me just follow up. Because I know that when you take out like half your brain, you can still function, right? You can take out, the left hemisphere and the right hemisphere will rewire. But then if you were to cut that in half again and you only get a quarter of your brain, would you still have consciousness? I mean, at what point does your consciousness disappear?
Yeah, Heather, how many subjects have you done this experiment on?
So we do it every day in the lab.
But seriously, what is the N on this?
The N.
Yes. When does it move to your feet?
I mean, it's a philosophical question. People say, if you take little bits of parts of the brain away, how much do you take away? How much of the brain do you actually need for conscious awareness? And some people claim that you only need the brainstem. Well, we know that that's not true, because if you take a full adult and you take away their cortex, or they have a damage to the cortex, they're not going to be conscious anymore. However, there are children who were born without a cortex, and they just have their brainstem, and they have some semblance of what we might call consciousness. Or
Are these what we call children of the damned?
Yeah.
You can't joke about Ann and Sally.
anencephaly. You can't joke about anencephaly.
I didn't know there was a name for it.
But seriously, I'll have conversations
Sounded like they were
with
fine.
dogs.
Yeah.
Right.
I'll have conversations with dogs. I can see dogs are dreaming. Dogs experience the joy of discovery. But is a dog paralyzed by self-doubt? Actually, I think I've even seen that. No, a dog with an especially aggressively disciplining owner seemed to be paralyzed, like I can't cross this line or the guy's going to hit me. And so do we study, how far back do we go from, what is it, Rhesus? What's the guy's
Rhesus
name now?
monkey?
But it begins with a K?
What do you,
The monkeys?
More information.
In Amy Farrah-Fowler's lab?
Capuchin.
Oh, capuchin?
Capuchin.
It's a C, not a K.
Kardashian.
Historical science is real.
Oh, wow. Petersburg reference. So, the Commonwealth of Kentucky. So, how far down do we go? Then there's a cat. Then I've spoken, albeit briefly, with birds.
Okay.
And it's a different deal, right?
So I think once we
Bill,
have
you're Dr. Doolittle as well as the science guy. Okay.
Once we have a measure of consciousness, then we'll be able to say, does this animal have it? Does a baby have it? You know, when is it emergent? But until we have an understanding of what it is, so there's certain theories of consciousness. One is that it's when you have a system that has a certain amount of integrated, differentiated information, that it will fundamentally have consciousness. That could be a computer. It could be any kind of system, a nervous system. So once we have an understanding of a theory of consciousness, then we can measure it and see what has it.
Well, and I think it's important to think about if you take out, quote, half the brain, you're essentially dealing with duplicated structures existing, correct? So there's going to be some asymmetry between left and right, but you're dealing with half of a brain that then is pretty much duplicating all of the structures you removed. Once you start chopping up that half, there's really no more duplicated structures you can start taking. So if there's one amygdala left, you can't take away that amygdala. There's nothing to take that place. So if you want to start chopping up cortex, or if there's an accident that compromises part of cortex, you have other parts of cortex that are similarly structured that can theoretically take over some of that function. Once you start getting into those limbic structures and the sublimbic structure, all that stuff, there's no more duplication. You can't keep like hacking it in half. It's not like a, calculus limit. Like, how much can I leave and still have the person be conscious?
Calculus limit, fundamental theorem
You
of calculus.
understood what I said?
I understand what you said.
I was
You
thinking
can't have a person with a brain the size of a penny. It's too little.
But you know what's really interesting?
You were saying chopping up, and I was sitting here just actually thinking of your vegan cookbook.
Broccoli Rob with brain is not bad.
The really interesting thing here is that you can take away the amygdala, which you can take
But
away
what about
both
the
amygdala.
hypothalamus?
You can even take away the hypothalamus.
Wait, Heather, you said that way too glibly.
Okay. Well, I mean, if there are certain people who are born with calcified amygdalae, so they have a disease actually that calcifies their amygdalae, so they become damaged and they no longer work. So you can be, let's say you can not have emotion, you can still be conscious. You cannot have memory and you can still be conscious. There's a case in England where he only remembers things for like 30 seconds. So each 30 seconds he writes down, I'm just now conscious for the very first time, and then I'm just now conscious for the very first time. But he's still having awareness. So the question is, how much, you can take away all these things, but how much of the brain is necessary to have subjective experience?
Yeah, actually, that is a great question.
How does he remember how to write?
Remember how to write?
Has he seen Memento?
This is very interesting.
This is a
That's
great question.
That's a very good question.
It's Michael's question.
He's seen it 3,000
That's a very
times.
But every single time, it's like the first time.
I love it, every time.
So there's something called procedural memory, which is different than declarative memory. Procedural
It's like riding
memory,
a bicycle.
Exactly. So when you learn something like motoric, like riding a bike or tying a shoelace, so what's interesting about this case in England is that he was a pianist, and he could, once he got started playing, he could play an entire piece of music all the way through. As soon as he came out of it, he didn't know where he was, what he was doing, whatever. But it's a procedural memory is with a different part of the brain called the basal ganglia, which you can engage in even if you don't have declarative memories or like memories, semantic memories about things or facts.
So it looks like all of your research is happening on people who have brain disorders.
Some of the best ways to learn about the brain is by seeing what happens in the natural world when it doesn't work. Because of all sorts of legal and ethical issues, we can't do that. So
On a living person.
We take what nature gives us, but that's, that's one of the things that, every brain lesion is different, every accident is different. There's a tremendous amount of unpredictability when you're dealing with any of these sorts of syndromes.
So you use the brain mapping to, is that the way to go to cure these horrific brain diseases like Alzheimer's and Parkinson's?
Just sleep more. I can cure that.
Well, I got a question. I have a question. I had my brain scanned a couple times on camera for hilarious science comedy. It seemed to me.
Bill, you got your brain, because I said, Bill, you need your brain examined. That's what you said.
Yeah, and it was empty. It was amazing. I just said it's not empty. I just don't use it. That's all. So it looked to me like if you could get another order of magnitude, that is to say, what is the current resolution of a magnetic resonance image? It looks like it's 0.5 millimeter.
Yep, or voxel.
Something like that.
Yeah.
It looked to me like if you could get another, instead of 0.5 millimeter, 50 microns, then you'd really be able to figure out what was going on.
This is where we're at.
Is that too
No.
reductionist to your point?
No, I like reductionism. I just was wondering if that was the pathway to
This is so where
answers.
we're at is that
I converted to reductionism when I got married.
Your wife
Happy
made
wife, happy life.
you reductionism.
so. In terms. The state of affairs now is that we have this technology to be able to look at the microstructure of the brain, so we can go in and measure the activation of 1 or 2 individual neurons in a monkey or even in a human when they're during surgery. And we can look at this very microstructure, and then we look at the macrostructure or the activation in things like fMRI, which is like a
functional magnetic
resonance imaging, which is sort of looking from very far away. But we need something in between, like a meso level, to understand how all these circuits are wired up. Because just looking at where the blood flows at a certain area, that's what fMRI is looking at, is too
coarse.
Exactly. And the other way is too fine. So we need something in between. And there are certain technologies that are being developed now, things like optogenetics, where you can actually look at the neurocircuitry and control.
So optogenetics, I did a little reading on that, and so you've got photoreceptive organisms you put in the brain or proteins, and then you follow the light that they emit. Is that how that works?
It's sort of like that.
Is this from Wrath of Khan?
Oh, God. God!
That was really worth it.
That was deep. That was
Carrying geeks up here on the stage.
That was
so these are ways these are ways to poke and prod a living person's brain without doing damage.
You can insert, you take these from photosensitive algae, you take the gene that codes for that, you insert it in a virus, which then inserts that into the animal.
Talk
so
faster,
far. Okay,
Heather.
basically.
Wait, you just said you get a photoreceptive virus that you stick in someone's brain.
Well,
did I just hear that?
You take the gene of the photoreceptive algae and then you want to transport it into the brain, so you do it via a virus. That's not dangerous.
So you're letting your virus do your bidding in someone's brain.
Yeah, and so then what happens?
With their permission.
It's like Khan. You put the thing in his ear and it goes into the... I remember. We all saw it.
That was creepy.
But it's a virus. It's algae that you attach to a virus?
No,
yes,
no.
Eugene, yes.
No.
I just want to repeat it one more time.
Heather, I got this now.
Viral algae, Eugene. Everybody knows this.
Look, let me see if I got this right. The algae has photoreceptive proteins.
Yes.
There's no good way to get that protein into another living body unless you attach it to a virus where that's what they do.
Well, they're going to start they're going to start transcribing, correct?
Yeah, and then what happens is that now wherever you insert this gene, now you've inserted a receptor that's going to be sensitive to light. So now when you shine light on it, the neuron will fire. And so what they've shown, let's say in mice, for example, is that you can shine a certain, like a blue light, and cause a whole circuit because it's being activated.
Dr. Berlin, hang on,
Yes.
seriously. Is it that you shine a light and it causes the neuron to fire, or when the neuron fires, it lights up?
No, okay. You're
Bill.
shining. I see where you're going. Well, when you shine the light, the receptors that are sensitive to light open, which then cause the neuron to fire. Because then there's a whole rush of, a whole chemical activation.
So the virus is introducing a sensitivity.
Which is detectable, right? The purpose of that is to make it detectable.
That's the whole point.
This is Schrodinger's viral algae, right? Physics joke, Paul.
Yeah, class. That's great.
So Heather,
Nailed it.
That's no ordinary
wait,
water
wait, so Heather,
bottle.
there are two sides to this. There's you want to repair people who have real neurological disorders, Parkinson's, but maybe you want to make people smarter or more, like you said, superhuman.
I'd love to throw a car. What do I need to do?
Yeah. So is any
How much algae do I eat?
are you or your people?
It's in her book. It's in the book.
Are they involved in this work, trying to enhance human intellectual performance?
So there's something called neuroprosthetics, and this is where we're using some of it right now to treat psychiatric illness, where we implant electrodes. It's called deep brain stimulation to help treat psychiatric patients. But there's things called neuroprosthetics where you can implant electrodes to help people, for example, who are deaf to hear, or to help blind people see. And that technology is already it's in pilot studies now.
There's a whole field of neuroengineering that is combining. Yeah.
And eventually, yes, we can do things like enhance memory, enhance attention by using these neuroprosthetics.
Is this like drinking Red Bull?
Similar.
Okay, but you're stimulating. I mean, our brain, as far as I can tell, is chemistry and electricity, right? I mean, is it something beyond that? You're manipulating either the chemistry of the brain or the electrical circuitry of the brain with magnetic fields or whatever else, right? So, all right. So, if that's the case, I know my computer uses electrical circuits. So, is there a future where we're going to attach your brain to a computer?
Yeah, I don't see why not. I mean, we already do. Yeah, we already, in a sense, are.
We're doing that after the show.
It's awesome.
But I have an old question about magnetism in brains. There are animals, apparently, that find direction on their own using some sort of ferrule, some sort of ferrous, some iron-bearing thing in their cells, in their brains. But we never got that. How did that get sorted out?
Well,
Bill, you trying to find true north? Is that you want to go north?
I want magnetic north. I'm good with that.
Well, the fact that MRI machines work indicates that there are magnetic properties. I mean, there's all sorts of properties to all of our bodies. So there's smaller, lesser magnetic qualities to our body, but no, we cannot navigate by them.
But
maybe you can't.
He doesn't ask directions.
No, but Bill, other animals got all kinds of stuff we don't have.
All right.
I have wings.
Newts can regenerate limbs. We can't. Eagles can fly. We can't. I mean, you just go on down the list.
All right. We were talking about brains.
Will it get to that thing where our brains really will be like a computer? We can hook it up to a computer and be able to speak languages without actually learning them. We will be able to download information.
Ask
via
Mayim,
an
apparently
external
she can.
No, the answer's no.
Wait, I think the answer is probably yes, though, right? Eventually. No, we can. There's
I'm with
already
you, Gene.
computers. I mean, there's computers that can translate pretty, like Google.
Okay, but we don't need.
We'll be able. We'll have,
Wait, can I have Google attached to my
I'm so
face?
excited right now.
Okay.
how
Maya.
when you
Mayim, wait, yeah. Mayim, go. You ready to bust a gasket here? Go. What?
No, learning a language is a very, very complicated. I mean, just to use that as an example, we're not translation machines. So, in theory, I could picture a world where if I had a catalog dictionary, I could be hooked up to something that would allow me to be a translation machine. But the subtleties of language and interaction and the way we communicate and answer questions and have experiences through language is it's beyond complicated that you could plug into a computer.
But
No?
so maybe if not having
The
being able to
Chinese
speak the
room
language,
dilemma.
but you could at least maybe read a menu in another country.
Sure, I will grant you that, yes.
So I know what the hell I'm getting when I'm in
I will
Paris.
grant you that. That's possible.
Besides eggs and champignons,
But meaning,
which is everywhere as a mushroom.
so you wouldn't understand another language, but you could technically translate it hooked up to a computer.
I'm
Well, transliterate,
guessing
that's
about
what
the
it is.
future, so
No, but I'm going to believe anything you say.
How when you chew on those pink pills and it shows you where you haven't brushed, how does that work?
Brilliant.
Wait, so Heather, do you think, I'm going to actually rebut Mayim here.
Yeah.
Do you
said rebut.
who would have thought some years ago that a computer would ever beat a human in chess? Who would have thought that a computer would ever beat a human in Jeopardy? So computers are moving pretty fast here. So why wouldn't the context of language be just another thing it learns rather than just a translated dictionary? Why should we put limits on the computers that have transcended limits we've ever given for them in the past?
They'll eat us as babies.
Okay.
One reason.
Those are not equivalent comparisons.
Yeah, that's what I'm
though.
saying. So intelligence is different. So knowledge, computers, if you want to look at it that way, they're already smarter than us. They can do math quicker than us. They can do calculations. They can translate into languages. They're much better in terms of holding a lot of information. And then why would we even want to sort of incorporate that into our brain? Right now we have our iPhones. We don't have to remember numbers anymore. Our computers do that for us. So then one of the questions is, what are humans still good for?
Yeah, in fact, the idea that you'd plug chips in your head to know things, this is not a chip in my head, but it's in arm's reach.
And it eventually
it's the same
it will
difference.
be. And it
just takes a few
eventually,
extra seconds.
Yeah, eventually it'll get smaller and smaller and smaller. You can implant the iPhone in your brain and you can talk to it and it'll give you information. So the question is, where does humans come in?
People
at some
already
point?
talk to their iPhones.
Right,
Yeah,
they
just-
do.
I gotta step in as an engineer here. I want to remind you that computers don't just come out of the sky. Somebody designs these things. I don't want to shock the guys over here. Yeah.
I'll believe it when I see it.
But then as far as communication in another language, I can easily envision, I guess a pun intended, a computer that can recognize faces and emotions on faces, and then that would enhance the translation of a language. Seriously, I don't think that's an extraordinary step.
But
I mean,
there's
it's complicated.
that famous sort of impossible sentence for computers where you say, time flies like an arrow, fruit flies like a banana.
Why is that impossible for a computer?
Because the two sentences
Why
are
does anyone
grammatically
say those two
identical.
things?
They're
Yeah.
grammatically identical, yet they have completely different meanings.
Why couldn't a computer learn it the way you did?
Right.
Because
Yeah, Chomsky.
Your timing of the words changed how they were perceived?
yeah. So what we don't know is whether the computer then has to have your life experience, a human life experience.
Consciousness,
Right,
some
that I was
might
going to
say.
say. What the real thing is, will it eventually have consciousness or experience or subjective states? What is it like to be
Can
a
it
computer?
ever have awareness?
Well, now
Yeah,
we
can it
get to the
feel-
Turing test, everybody.
Oh, very good.
I said the Turing test, guys, just because I
That
could.
was pretty impressive.
Thanks.
Some great science fiction storytelling involves power of the mind. Telekinesis, mind control, mind reading. Is anyone working on this? Is it in the future? Or is it just a pipe dream?
Yeah, so there's studies, let's say something like mind reading. There's studies now where you put someone in a scanner and you show them different pictures or even movies and you see what the sort of neural signature is of that. And then you, again, put them in the scanner. The experimenter doesn't know what they're looking at. They're only reading out their brain activation. And they could very reliably predict what the person is seeing. And then if you take that a step back, and you can even look at what a person is imagining. So over time, the more precise this gets, I can definitely envision someone just reading someone's neural sort of activation and predicting what it is they're thinking about.
So you'd have to walk around with some kind of neuromap visor so that you can detect if someone is being turned on or turned off, or be highly useful socially.
Yeah.
But you're
if you're
describing
autistic,
like
if
super extreme guesstimation. Like meaning not mind reading, you're just talking about a very, very, very
yeah,
perceptive
you could be
person.
wrong. You could.
Well,
yeah.
that's
but
what
the better the technology, the
but-
more we understand about the brain, the closer you will be to getting right.
But successful charlatans or so-called mentalists or magicians, they have this ability at some very reasonable
Right,
well,
but-
probably through facials. Go ahead.
Well, yeah, there's a lot of subtlety that that's not mind reading, right? That's a very subtle fine tuning into body language, gesturing, shifting of basically the air around people. But there's nothing magical, mystical about it.
Your grandmother is here and she agrees.
I'm getting something. Does anyone,
It came
is
in on
anyone
the,
having
on the,
trouble with a white
the
car?
headpiece.
A white car.
But I'm sorry, if we take what you're talking about, Heather, maybe 10 steps further, is it possible that in the future it would be possible to kind of record your consciousness and then market that as I would be able to live as you for a day through a sort of kind of VR virtual reality playback?
Ooh.
I don't know if you could ever. That's a very
Just say yes.
philosophical question.
I'll tell you what.
Yes.
I
want to be a lady for a day.
Guys,
What would you do?
I would buy that URL right now, man. Ground floor.
But actually, another study that I'm involved in, we're doing something called hyperscanning or dual scanning, where we can scan two people at the same time, having an interaction, and kind of seeing what's happening in the space between two people. Because as I said before, I can never get into your brain or really know what you're thinking, and that's what communication is. It's about the space between, and now we're seeing what's happening in your brain when you're actually really taking in what I'm saying, and vice versa.
And also, much as, as scientists, I'm sure we'd all agree. Yeah? There are things that we can't see and that we can't understand, but there are also things that we know now as scientists, things like pheromones. There are things that occur, for example, between two people that are not necessarily detectable in all the other ways we're looking, but there's something that happens that, again, we don't need to write off as magical and mystical. We may not be able to measure it yet, but yes, I think we'll get there in more ways.
Okay, so let me add, we'll end the show with this, this exploration. If you want, Heather, you're on really, dare I say, dangerous territory, because the more you know what the brain is and what it does, as a scientist, what any scientist wants to do at the end of the day is control it. Yeah, that's the evidence that you know what it is you're doing.
You want to make predictions.
Make predictions. Have those predictions come true, and you say, I know how this thing works. So if the brain is your laboratory, and you say, oh, here's this, I've just discovered what makes two people fall in love. Now you make a love potion number 9, and you control people's behavior and conduct. Do you have another team of ethicists behind you looking over your shoulder at your conduct?
Yes, it's the CIA.
Yeah, I mean, there's a whole field of neuroethics, which are talking about issues. But yes, I mean, ultimately, what we're going is from correlation to causation. When I say we're going into the brain and implanting electrodes for a good cause to treat psychiatric illness, we're controlling emotions. And, if somebody who was a
emotions
psychopath,
that are socially regressive.
yeah,
right? So,
but you can actually, I mean, if we know exactly what the right formula is for, say, love, I mean, you can stimulate an emotion in someone and they'll label it as love. I mean, but no one's there overlooking my shoulder saying, there is an IRB, there's a board that, like...
IRB?
The Institutional Review Board, yes.
that makes sure that you don't make people fall in love when they're not supposed to. Okay, good. Okay,
exactly.
Feel super safe.
Okay, but the day would surely come where you can make someone smarter if they can afford to pay you. You could cure them if they can afford that. You have all kinds of neurological disorders. I'm just wondering, what is the dystopic future of this, and what is the utopic future of this?
Well, one issue is that it could be that only people who can afford, let's say, the neural implants get them, and then they have an advantage. It's just like, and then everybody will have to, so like performance-enhancing drugs, in sports, the reason they outlaw them is because if one person has it, they have the advantage, everyone else has to do it then.
Same with mental illness, right? In terms of access to mental health care and mental,
Exactly. I mean,
right. Once one person has a mental illness, everybody else feels like they have to have a mental illness.
No, but I think what you're getting at, there's a dangerous possibility of sort of narrowing the field of who is well, who is smart, who is desirable, who is accessible, who gets access to care. Not to bring it down at the end, but that could be dangerous.
Yeah. And so let me ask each one of you, what's the scariest future of neuroscience you can think of?
Oh, can we end on a positive note?
Oh, you want a positive note? Okay.
What's the greatest?
What is the great? What is the? You work in this field. What is 50 years in the future? What is that world gifted to us by you and your research colleagues? 50 years from now, what is that?
Wow. Well, what I would hope is that we can really have a full-scale map of the human brain going all the way from the genome to function and to mind and brain. And once we have this full map of the brain and how it works, then we can help prevent things like Alzheimer's. So rather than looking at treatments, we're going to look at prevention. You know, if you can go in and tweak the genome a bit so that people don't get these kinds of mental disorders to begin with, then we don't even have to worry so much about the treatment side of things. So that would be wonderful.
So can you treat the genome in an adult? You treat the genome in an adult, and then that fixes their brain as an adult?
That would be great if we can do that, yeah. If we can even do it in an adult to change it, yeah.
Gotta ask, though, from an evolutionary standpoint, why is it that that mental illness persists? If it's really especially dangerous, wouldn't it have been eliminated from the gene pool? So I suspect it's not, in the biggest picture, that deadly to have a mental illness if it's manageable. That is to say, germs and parasites are much more likely to kill you than being mentally
unstable,
different. Yeah. And so I just wonder about this whole thing when you go to predict the future without taking into account, let's say, the flu that killed more people in 1918 than World War I did. And so the other thing is these questions, I think, are really only useful to a society that can afford it, right? The people that are more successful at having an overall health in their tribe or their society might do better than the one that can
just
get
in terms of quality of life. Well, there are two things there. One is that certain things do persist, like, for example, being a sensation seeker, being really impulsive. That's a quality that got people out there and, you know, discovered America, right? These kinds of traits which we might call, you know...
By the way, that probably killed more people than who actually survived and came back.
Artistic ability and mental illness, right?
Right.
Yeah, I mean, there's not, and that's to say that everything with mental illness, there are some positive things about being at the extreme ends of what we consider to be normal. There is no such thing as normal. But what studies do show is that the most amount of any disease, cancer, you know, all sorts of physiologic diseases, the thing that causes people the most lowest quality of life and distress are mental illness, because they don't die from it, but they have to suffer their lives.
And often they have children and pass on genes that may be predisposing to future mental illnesses. It's a really sad discussion. I don't know. We're trying to find something uplifting.
Okay, we got to wrap this up. So Mayim, on that really depressing note.
Yeah.
What's in your future?
Personally, or in the field of neuroscience? What do you mean?
Yeah, your personal future. Yeah.
Oh, you're looking at it. No, I mean, like, whatever. I have this book. It's called Mayim's Vegan Table. I work on the Big Bang Theory, and I have 2 kids, and that's my life.
But 50 years from now, what is neuroscience going to be doing for us? 50 years from now.
He was said personally, not neuroscience.
Right. Good.
I was a good listener.
I'm sorry.
I can measure that, actually.
I'm sorry, what did you say?
Let me offer some sort of concluding remarks here. I think I study the universe, and the interesting thing is that there's this universe inside our heads that is perhaps less well known than the universe that extends back to the Big Bang in time and in space. And so it's curious. Maybe the big challenge here is studying. You're using your own brain to study a brain. You're not some other entity studying the brain. And that prevents some questions perhaps from even being asked, because you don't even know the right question, because the brain is asking the question about the brain. And Carl Sagan is famous for the saying that conscious humans, are a way for the universe to know itself. And no, we're not the universe, we're in the universe, and we use our brain power to decode the universe. I'm intrigued by the fact that the real future here might just be in our minds, and maybe we will learn what questions we're not asking yet. And those are the questions that keep me going every day, because that's the future of discovery in any field. So join me giving a very warm thank you to this brilliant panel.
It was cool, man. Great job. Great job, man. Great job. Great job, you guys. I just thought it was cool.
It's Q&A time. We have some microphones on the aisles. We can bring up the house lights maybe to half. And what we prefer is just to find one person to direct the question to, because if all 12 of us answer, it takes all night. So if you can be specific about it. Sir, you're up front.
Hey, how are you doing?
Hello.
So you talked a little bit about the idea of there's these people, superhumans, right? And so there are people out there who have what I think is called savant syndrome, who have some kind of amazing mental abilities. They can like learn new languages in a week or do really rapid calculations. So what's different about these people's brains? Is this something we all have inherently able in our brains, and could we hack it to enable that ability?
Wait, I recognize that question. You're the guy who won this contest, aren't you? Yes, he won a contest. Well, so thank you.
Well, you're welcome.
Yeah, and they put you first on the line.
Well, they told me to rush up.
Excellent. Okay, a great question. I think, we all want some of that ability, right? So what's up with that?
Yeah.
How can we all become magic?
I don't have all the answers, but I think what savants is they seem to be wired slightly differently, and so they seem to have usually these isolated areas of specialization, but sometimes at the cost of other parts of the brain, development of other parts of the brain. So it's not necessarily a good thing to be very, very good at just one thing and at the cost of other things. And the only way I think we can enhance our cognitive abilities is with working at it. It's like anything, like with losing weight, you have to work at it. So I don't think there's a sort of magic pill, but it has to do with the way that their brains are wired slightly differently.
Okay, so using the word wiring, so
Yeah,
in the future you
connectivity.
can adjust the wiring. If you have a if you have a savant, is there an ethical question about whether you would change that about that person?
Yeah, I think there is. I think it's with like anything. Even with a psychopath, they don't come in for treatment.
Gestures
no,
too.
Even psychopaths.
They might
Need to
enjoy
be asked
being that
whether-
way, So if they're not a threat to other people, or if they're not in distress, I don't think that we should go around just changing people for the sake of it.
Question here, yes.
Yeah, so since we have the comedians here, I don't know if you guys have thought a lot about the intersection between comedy and neuroscience.
I have, yes.
Yeah.
Good. Well, no,
I wrote a paper on the physiology of laughter in college.
Great, yeah. So
Actually, he did. That was his.
Yeah, it was all wrong, but so I wrote the shit out of it.
All right, perfect. So these guys are up here providing great comedic interjection, and not everyone can do that. Not every brain works that way. So maybe we could hear from one comedian and one neuroscientist, why.
Or how about a neuroscientist who is a comedian?
Well, I can't ask all of you.
I mean,
so who?
Yes, no, please.
So Maya, go.
Why are they funny? Why are you guys funny?
I don't know if I can answer that, but I can say that.
Well, can I add that when she couldn't say this about herself. On The Big Bang Theory, her timing is impeccable.
That's my mother. Thank you, Mom. That's your mom.
Wait,
Yes,
what?
from 1991 to 1994, she was Blossom on the show Blossom. Yes. And you were the young Bette Midler in The Rose.
Yeah.
Yes.
In
Beaches,
yeah.
yeah.
No, I'm happy to let you guys also speak to it. In terms of what's funny.
We're not. We want you to speak. Go.
No, but in terms of what's funny and why are things funny, there is a really interesting field of sort of understanding the timing of how complicated it is. It's complicated social interaction, but I think for me as an actor and as a scientist, what I'm aware of is what we constantly do is we're constantly scanning and tracking, and people can do it better than others. Stand-ups can do something that I can't do, right? I can't do improv. There's a different set of skills that actors and performers have. But the joke that we tend to be neurotic, that we tend to be constantly looking to make someone feel something is a very complicated thing about being an actor. And I didn't think about it as much when I was younger, but when you meet other actors and when you talk about process, which a lot of people laugh, they figure oh, we're paid to be funny or we're paid to make people believe something. It's a very complicated process by which
I need to make you feel something. I need to make you believe something, and I need every single person to feel that. So if you're a stand-up, you're working with a room of people. When I work in front of a live audience, I need everyone to feel something. And it's a really complicated interaction, especially if you work with a live audience. It's very different than not, because it is a constant tracking.
Heather, are comedians subjects of your...
Well, yeah, actually, so this is really exciting stuff. This is a new area of research we're going to. It's actually the neural basis of creativity and improvisation. And so what we find is that whether it's jazz improv or comedy improv, there's a certain neural signature involved when people are improvising. So you can put people in a scanner, and even freestyle rappers, right? So you give them a memorized rap, and then they can freestyle, or you give a musician a memorized piece or improv. And when they're improvising, what they find is that a part of the prefrontal cortex, the medial prefrontal cortex, becomes extra activated, and that has to do with internally generated ideas. And the dorsolateral part of the prefrontal cortex becomes deactivated, and that has to do with sort of self-awareness and monitoring your behavior. So you almost go into this free-flowing state. If you become too aware, you mess up. You're not good at improvising. You have to kind of lose yourself, so to speak. And that's what the neuroimaging shows.
I have a follow-up. Is there any connection between improv and optimism?
I don't know. Actually, wait, one of the studies showed that when they were improvising, they had increased activation of the amygdala, which could be related to positive feelings.
That's your brain part.
It's kind of my thing.
That's interesting to know. Right here, sir.
Yeah, hi. I have a question. I actually had a couple of questions, but then when you guys mentioned eugenics...
That's kind of your thing.
What's your question, Himmler?
Wow. Wow.
Too soon.
Too soon.
Oh, that kind of shades my question, doesn't it? I was actually, all I could think about was the movie Idiocracy. Now, I don't know if any of you guys have seen that.
Idiocracy.
It's kind of a scary look at what might happen if
dumb people keep breeding.
Thank you.
It's
yes.
Luckily, make believe.
So, like, if you know. Okay. So, my question is to the neuro folks over there. I don't know if you've seen anything going in that direction or not, or.
Have you seen a genetic predisposition in society to become idiots? Or...
I didn't see the movie, so I can't speak to that.
Well, this is going to be, I'm trying to be like sort of PC. Well, the one thing is that with evolution in the past, right, if it was survival of the fittest, then those who just couldn't make it, and they would die out, and then there would be certain traits that would have evolved and survive. But now we have all sorts of
ways to keep those people around.
Exactly. So it's kind of messing with evolution a bit.
Idiots alive.
Yeah. So who knows what's going to happen?
If we were in Washington, D.C., there'd be a GS-level joke right there.
Question right here.
I've got kind of an in-depth and specific question, I guess to the scientists and I guess to the neuroscientists here. Based on quantum theories of the mind, what's your take on the idea that consciousness originates at the quantum level? And if you're familiar with Schrodinger's equation, the very fact that observing something changes the outcome, so the mind observing consciousness, what's your guys' take on that?
Yeah, I can offer something on that as well. So, quantum
the cat
physics
is actually dead.
Quantum physics has sort of mysterious properties that are real, but they defy anything your five senses or more have ever experienced in your life. So you say, well, that's weird, but it's real. It happens. Particles pop in and out of existence. You look at it, and then it changes into something else. This is the behavior of the universe on the smallest scale. Because it has all these mysterious properties, what I have found in my experience watching people think about the world is they have this urge to insert quantum physics where there's something where they don't otherwise understand what it is. So we don't really understand consciousness, quantum physics must be at work, all right? So it's this, and in fact, the more they invoke quantum physics, that's the evidence that they know least about what it is they're talking about.
Well, I admit that. I don't know what I'm talking about.
But I think the Heisenberg uncertainty principle, I mean, I do appreciate this notion that any observation of something alters what it is, how we perceive it, and how we describe it. I appreciate that.
When I observe you, you don't pop into a different quantum state. You're a macroscopic entity. Large things
6'7"
average out these principles so that we have a macroscopic world that lends itself to macroscopic discussions.
Just tell him to sit down. You just want to tell him to sit down.
If we were the size of particles, yes, me beaming eyes at you with a light would pop you into some other part of the universe. Yes, but you're big, so it doesn't happen. Okay?
Is that a fat
I'm
joke?
just saying. Okay. And it would be cool. It would be cool if we were like particle size and you walked through a doorway, okay? You would diffract, okay? Because that's what light does. I mean, it'd be funny if Planck's constant were much larger than it is. Weird stuff would happen all the time. Okay, so yes.
Can I just bring us to the brain for a second? Okay, so there's this. I just want to diffuse this theory because I always get this question about the quantum theory, and there's this Roger Penrose, who's a mathematician at Oxford, and Stuart Hammerhoff, who's an anesthesiologist. They came up with this theory of the quantum theory of consciousness, basically saying that at some level, at the structural level of the neuron, is where these quantum effects can sort of take place, and that's where consciousness lies and the rest of it. But there's no evidence for that, and also the temperatures at which these effects would have to occur, they'd have to be cooler than the temperature that the brain is currently at. So there's a lot of things that go against this idea, but again, people tend to want to put together something mysterious with something else mysterious, but as far as we know from the field of neuroscience, there's no evidence.
Can I ask a follow-up question about this?
Okay, only if it's quick, but go.
No, that's
He's right behind you.
Over here. Oh, I thought it was over here.
But I was very polite.
I didn't get the.
I'm cutting the line.
Sorry, cut the line. Yes.
Doesn't this imply, this idea, does that imply then that consciousness has mass, and do we know that to be true?
I gotta say, you guys, as an engineer, at some level, you can measure like with a logic analyzer or whatever, you can measure the voltage without screwing up the circuit. At some level.
I don't understand what you're saying.
Wait. If one day we establish consciousness as the sum of some energies within the brain, then by E equals MC squared, consciousness has a mass equivalent.
That's what I'm saying.
That's it. Okay.
Thank you.
Yes, sir.
Okay, so tonight's discussion was mostly centered upon human neuroscience for obvious reasons. But there was a few mentions about neuroscience and consciousness and whatnot of other species, and we do know that some species are quite smart, and not just like our close relatives like great apes, but also toothed whales, some birds like parrots and crows, and even I recently saw the video that looked like it was unedited of an elephant painting an elephant. So
was that on YouTube?
No, it was not. It was not.
Okay,
was the elephant soapy?
Yeah.
I saw a dolphin playing chess. Is that real?
Well, not just one. Like my real question is, what might consciousness be if it has arisen in different lineages of living things? What might consciousness be for them, and also what might it be for, say, a possible alien life form?
We got a Hindu here.
So Heather.
Yeah.
Heather, so conscious, big-brained mammals out there. Can we learn about our consciousness by studying them? You work on lab rats to learn about
I don't
other
work
things.
on rats, I work on humans. But yeah.
Oh, you work on, excuse me. You
Human.
ever hear what she said that? I don't work on rats. I work on humans. Yeah, okay. Yeah, we all feel better about that. Yeah.
Well, they're different.
Yeah.
They're different.
Different IRB protocol.
Yeah, exactly. A totally different protocol.
That is rich. The B protocol. That's comedy.
Different protocol. Yeah.
Yeah.
So what's really, there are two different things. There's intelligence, there's consciousness. A bee can have consciousness. It could feel a sensation. It can sense something. It can do something very simplistic. So you don't need to be able to play chess to be conscious. We know that in certain creatures, like in dolphins, in whales, in humans, there are certain types of cells called spindle cells, especially in animals that are social, and that might have some kind of link up to awareness, or at least some kind of a self-awareness. But until we have a fundamental theory of what consciousness is, we won't be able to know for sure what something has. We only can look at behavior. Even with humans in the lab, you have to just ask them, did you see that or not? Were you aware of that or not? That's the only measure we have.
I saw a comic of two dolphins, one swimming next to another, and they're referring to the humans up on the shore, and one dolphin says to the other, they face each other and make noises, but there's no evidence they're actually communicating.
Right.
Yes, right here.
Yes. First I have to say, what an awesome panel. And Bill, you did great in the debate.
Good, thank you.
Thank you.
I'm really starstruck just being here. But anyways, I want to ask two of the neuroscientists and to Neil, because I think you've been on stage. I think a lot of you guys have been on stage with them. It's a rather controversial position held by Sam Harris. About
who was
whether,
one of my colleagues at UCLA. He was
and
in my
by the way,
class.
let me preface this by saying I think he's a brilliant orator. I think he communicates very well. I just know he's got he's a great thinker too, but it's trying to parse out whether we agree or not, or whether there's consensus. And the question is about whether or not we have free will.
Oh yeah, I can answer that.
Free will.
So as far as we know from neuroscience.
Point is, Sam Harris recently published a tract on the assertion that we do not have free will, and the evidence cited for it comes from neuroscience.
I must answer this. I have no choice. Sorry, you guys go. Or do I?
Free will,
so
what's
as
up?
far
What
as we
gives?
know, it started with Benjamin Libet's studies in the 1980s and all the way until modern studies now that the sense of free will is kind of an illusion. Free will is an illusion in the sense that your brain decides first and you become aware of it after the fact. And we know this from a whole series of studies from measuring neural activation. There's even studies now where you can put somebody in a scanner and you could predict, for example, up to 10 seconds now before they're going to decide whether to go left or right or press the left button or right button by just reading their brain activation.
The brain pre-decides.
Yeah, the brain, it's
you have
called the
conscious
readiness
awareness.
potential. So it kind of is gearing up and you can start to read how the neurons are firing and that it's going to go sort of toward one way or another. At a certain point, you can make that prediction well before the person becomes consciously aware that they've decided to go left or right.
Big N, too. Talking big N.
Yeah, that's a big N there. You're right. It's pretty well established that, yes. Yeah.
Okay, but does that alone negate free will?
Well,
your brain has free will, presumably, to do it.
The brain decides. Your perception of I made the decision only comes after the brain has already kind of decided.
So we are
But hold on, I made the decision is my brain that's I making the decisioning.
Right.
So let me ask you, what
okay.
is this phenomenon? I sure hope I don't see my keys in the trunk of my car and close the lid on it. What is that? You know what I'm talking about?
Why does the brain keep putting keys in the trunk?
You feel that you're going to make a mistake, but you go ahead and make the mistake anyway.
So this is the thing. Everybody's talking about consciousness, but much of our behavior, much of what we're doing is happening outside of awareness. So you're already halfway there before you're realizing, oh, where am I going? What am I doing? And so if we had to be consciously aware of every single move we made, the brain doesn't have the capacity to do that. Consciousness has a limited capacity, but the unconscious processes seems to be unlimited.
Which is not to say we also couldn't call that free will, right? In an unconscious way.
You're unconsciously, yes, you're unconsciously making decisions freely all the time.
Good answer. All right.
Good.
No, I like that answer.
We did it.
Yeah.
I'll take two more. We only have time for two more questions. I'm sorry for the rest of the line there. Sir.
Okay, well,
But I see someone really young in the line there.
Aw.
No, sir, I'm not referring to you. Okay,
Does that mean I'm
okay. We'll take the last two here and just one more over there. Sir, go.
Okay, the question is kind of following up on the issue of awareness and heightened awareness and the use of psychotropic drugs and hallucinogenics in treatment of brain disorders.
Oh, okay. Yeah, so...
And I have one other question.
Yes.
How many people on the panel are left-handed?
both these? I'm a little of
Ambidextrous,
both.
yeah.
We'll get rid of them quickly. Eugenics. No, just kidding.
No. Once again, left-handed people have certain advantages to certain things, right?
Yes.
It's hilarious old joke. You want your kid to grow up to be a left-handed relief pitcher because he or she is going to, well, so far, make more money.
Actually, people who are left-handed have less lateralization, so language tends to be more lateral. It's not completely in the left brain, but there's
lateralization.
More activation in one hemisphere of the brain than the other. So, like, language tends to be lateralized, or there's more activation in the left hemisphere. But people who are left-handed, there tends to be more activation in the right hemisphere, above and beyond those who are right-handed. So there's less lateralization. There's more sort of distributed across the brain activation.
I'm about 20% left-handed.
But the point of the the drugs, the treatment, there are actually now studies at where I'm at, they're using ketamines as a treatment for depression, which used to be a club drug called Special K, and if you take too much of it, you can dissociate. It's not good.
We're doing that later. In the name of science.
Hey man, you guys like want to dissociate later?
No, but I got some Special K. But I think also treatment for depression, it's sort of one set, but there is a field that's looking at sort of understanding altered states of consciousness and our perception of altered states of consciousness, probably beyond the scope of
and even using drugs like ecstasy for therapy and treatment for PTSD.
And therapeutically with sort of well-trained and very elaborate supervision, it can be very helpful.
Elaborate supervision, it can be rad.
I just have a quick, a quick follow-up on that, Heather. Is there any mental state beyond the one that is alert and bright that can be chemically induced that is a greater mental state of awareness than the one you started with? Because it appears that every time you do anything chemical to the brain, it disrupts your ability to know what reality is.
Okay, you can
no, go ahead.
Well, first of all, even just in our non-drug-induced state, our perception is different than what's necessarily out there in reality.
Sure.
So there's all sorts of illusions. You don't see what's right in front of your
Oh,
face.
yeah.
So there's that. So anytime you add a certain kind of chemical, you change the neurochemistry of the brain, it's not going to say that you're going to be more aware. You're just going to have a different type of awareness and perception.
But when you have things like synesthesia, when you have senses crossing from LSD, those kinds of experiences, these are kind of qualitative or quantitative questions, right? Yes, you're having more experiences that are much more complicated and much more, trippy than what we're experiencing in our normal state. But I think, that's subjective also.
And you've read about these conditions.
I have.
Yeah.
In Life Mac.
So my follow-up question is, what if the way you see blue is different than the way I see blue?
It's like really red. It's
yeah.
like the same.
Last question on this side of the aisle.
Big
Yes.
pressure for the last question. Something I've always been fascinated with. You guys talked about like telekinesis, mind reading, and all that. Where does deja vu fall into the spectrum? We've all experienced it. We've all had that moment or many moments that we know it's coming, but we don't know why.
Have you asked this before? I waited for one of you. I'm sorry.
It's only because I'd already heard you ask that question. I was like, ah!
Have you heard George Carlin comment on deja? He says, you ever walked into a room and you were sure it has never happened to you before? That's vujade. That's what he called it. So deja vu, what do you guys say about that?
I'm not an expert in this area, but I think that there's a sense that something is triggered in the brain where you get a sense of familiarity, and then you attribute that to what's happening around you. And there's also studies that show when you lose that sense of familiarity, some people think that a person they know very well is an imposter. So they think like their husband or wife is an alien because they lose the sense of familiarity. And sometimes that same neural circuit is activated in any situation, and they feel like they've been there before, or they've experienced it before.
I think that's sort of speaking to the sort of redundancy that occurs in the brain, that the notion is that there are many ways to get to one destination, and sometimes pathways get triggered that have this sense of familiarity because you've literally activated a pathway that is redundant. I mean, everything's got to fit in there. Sure, there's miles and miles and miles, but there are certain things that are going to trigger redundant kind of pathways that also, again, have that sense of I've done this before, and your brain thinks it has.
Yeah, and also the other thing with that, memories are malleable. Each time you remember something, you can reconstruct it. It's different than the memory of your iPhone. The picture that you look at will stay the same. 10,000 years from now, that picture will be exactly the same. But every time you remember something, it slightly changes. So we can rewrite history in a way.
The last question of the evening. Yes.
If someone was born in space, how would that affect the way their brain develops?
That's great.
Well played.
Wait. How old are you?
9.
You're 9. It's past my bedtime. Is it past your bedtime? I don't know.
Yeah. When you see your parents, let them know they're irresponsible. Unless you drove here. Child genius.
So first, that's a brilliant question, first of all. Second, I can take it only so far. Maybe Heather has, and Mayim have some other comments on that. But there are a lot of things in our lives that, we evolved to be on Earth with our force of gravity and the kind of light that's here. And so there are all these things that shape what eventually we call common sense. And things fall down when you let go of them. In fact, the act of saying let go means to drop it, whereas in space, letting go doesn't drop it. It just sort of stays there. So your awareness of what is normal is really different. And we don't really know. It's kind of unethical at this point to just do that experiment. Send up. Let's see what happens to my kid after she's born in 0G. We don't really know. But from the experiments done, there are things about your ears. Inside your ear, you get a sense of balance. Okay? Your ears tell. I'm just saying. At the fitness center, I do that little balance thing, so you can do this, all right? So your sense of balance comes about because you're in a gravity field. If you got born in space, and that's all you know, and then we put you here on Earth.
Right.
Did you see the end of the movie Gravity? Mm-hmm. In it, Sandra Bullock, who's been a long time in space,
the only accurate part of it.
She crawls up on the beach, and she realizes she hasn't had to walk in a long time. Her sense of balance had grown accustomed to being in 0G and had forgotten what it was like to walk on Earth.
Dr. T, I gotta interject this.
Do it.
You don't know that.
Don't know what?
You don't know that if a kid were born in space, that he or she came back to Earth, couldn't figure it out. You don't know, like he or she may have actually a whole different, deeper understanding of inertia and physics and friction. That I admit, we don't want to run that test.
Uncle Bill is right. We don't know, okay?
But our closest guess is Sandra Bullock.
Yeah. Yeah, best evidence is what happened at the end of the movie Gravity. That's how. Thank you all for coming to Startalk Live!
Awesome.
Thank you, Michael.